Hello there, I'm Susan Wray, Editor-in-Chief of Physiological Reports, and it's my pleasure today to speak to Mathew Piasecki, who is one of the co-authors of a paper we've recently accepted. The title, it's possibly one of our longer titles, is Motor Unit Number Estimates of Neuromuscular Transmission in Tibialis Anterior of Master Athletes, Evidence that athletic older people are not spared from age-related motor unit remodeling. So, Matt, with that by way of introduction, can you introduce us to your co-workers in the team, and are you all at Manchester Metropolitan University?
Hi Sue, from Manchester Metropolitan University we have myself, we have Alex Island who's a postdoc here, Jess Colton who's a PhD student, and Jamie McPhee and David Jones who lead the project from here. We work with colleagues just down the road at the University of Manchester, Agnieszka and Martin, who are both medical doctors, and they're involved in some of the screening and recruitment of the older participants. Then we also have colleagues in Canada, Dan Stashik and Andrew Hamilton-Wright, and that's the full author list.
Thank you, Matt. So a truly international team there. Can you tell us, Matt, what was the interest of the team in this study of motor unit number?
Well accepted fact, as we age, we experience something we refer to as motor unit remodeling, whereby we end up with fewer motor units and those that remain are larger. And this is due to an ongoing process of fibre denervation and re-innervation. Recently, we showed that this happens in the large VL muscle, the vastus lateralis, a muscle, one of the quad muscles, where we know that age-related atrophy is a problem. And we've shown that this occurs in healthy older people that would not be described as sarcopenic, and people who do not have any mobility or necessarily any strength problems. So the loss of motor units is undoubtedly a contributing factor to total muscle atrophy. So the next obvious question is, what can we do about it? If anything at all, what is the best intervention? As there are no pharmacological interventions, the obvious suggestion would be exercise, as we know that it has countless beneficial effects on muscle and physiology in general. So we wanted to test that hypothesis. Does lifelong exercise attenuate age-related motor unit remodeling? Or could we go even further and say that does lifelong exercise even prevent age-related motor unit remodeling?
Thank you. Yeah, important questions of which many of us are very interested in. So, Matthew, were there any particular challenges? I mean, already I'm looking at master athletes. So do you have a cohort of master athletes? So how did you conduct the research?
We do, yes. We're quite fortunate here to have what we believe, whether or not it's true, to be one of the largest cohorts of master athletes. So we think that some of the best master athletes in the country have actually been through the lab for testing. And we recruited these over a few years from various competitions and magazines.
So with that grouping then, what was your chief findings? What was the most interesting outcomes?
I think the most interesting finding, although it could be viewed as a negative finding from some aspects, is that this loss of motor units with age seems inevitable, and the lifelong exercise does not seem to prevent it. So exercise undoubtedly has benefits elsewhere, but it does not seem to prevent motor unit remodeling in any way in this particular muscle.
Right, so you say in this particular muscle, so do you think you were not necessarily looking in the right place, or do you think this finding will be generalized to other similar muscle groups?
I think, this muscle is chosen because, one, the method is well established, and two, it is quite heavily loaded during running, so you would assume that throughout the life it is a muscle that has been used. However, having said that, it is not the primary power generator during running, so perhaps if we looked at the quads, we might see a greater beneficial effect of exercise. And the quads will be also more interesting, not necessarily more interesting, but interesting because we know we see a greater level of atrophy there.
Yes. So would that be how you're going to take this work forward, or have the negative findings dulled your appetite?
No, I think it certainly hasn't dulled it, although it's not the ideal answer. It might be one of the first studies to say that, hang on, exercise doesn't prevent absolutely everything, but it's to look at other muscles, in particular the quads, is certainly one of the next points we need to look at. We also need to look at what type of exercise. I don't think it's enough to say a person that has exercised. We want to know what form of exercise they've been doing. And the obvious question here is, are sprinters better protected than endurance runners?
Indeed. Okay, well, Matthew, thank you very much for sharing those insights into your paper. I'm glad that Physiological Reports does publish negative data, because as you're probably aware, there are a lack of outlets and the community suffers if negative findings are not reported. So thank you very much, Dr. Piasecki.
Thank you.